Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, welcome to Lesson 14, Reflections, Classwork Exploratory Challenge. Think back to Lesson 12 where you were asked to describe your partner how to reflect a figure across a line. The greatest challenge in providing the description was using the precise vocabulary necessary for accurate results. Let's explore the language that yields the results we are looking for. So on the right here we have triangle ABC that is reflected across segment DE and maps onto triangle A', B', C'. Use your compass and a straight edge to construct the perpendicular bisector of each of the segments connecting A to A', B to B', and C to C'. What do you notice about these perpendicular bisectors? Okay, so to construct a perpendicular bisector, the first thing we have to do is draw a segment. Actually, let's just change the color, leave it thickness the same. So I will do A first, so draw a line, and of course you're going to use a straight edge to do this. In other words, get a ruler. So I'll do one that way. Okay, so if I take this ruler, you just line it up like so. I'll do this one in green, and you draw a segment. So this is how you would do it with a ruler. My program just does straight lines, but you can't do that on paper, so I might as well do it this way. And I'll do this one in red. So this is a segment from C to C'. Okay. So, first thing it said to do is use your compass and straight edge to construct the perpendicular bisector of each segment connecting A to A'. So we had to make the segments first, so there they are. And now we're going to use a compass to construct, and I'll use the same colors for each line. So you put your compass on the point, and you go just beyond center, and you draw a circle. Move the compass over to the other end. Let me flip it so I'm not off the paper. And you put the compass on this end, and you draw a circle. Then I'll change it to red, and I will do the same thing I just did, and I'll put my compass point at C'. Shorten this a little bit. You want to be further than halfway but not longer than the segment. Draw a circle, move it over to C, draw a circle, and then finally I'm going to change it to green. Move it to B', open it beyond halfway, draw a circle, move it over to B, and draw a circle. Okay, so then it says, once we've done that, it's asking what do we notice about the perpendicular bisectors. So if you look, right here is where the two red circles intersected. Right here is where the two red circles intersected. So if I drew a line segment from those perpendicular, or from those two circles centered at each end, then the perpendicular bisector of the blue line, the perpendicular bisector of the red line, and the perpendicular bisector of the green line are all the reflection line DE. Okay, so let me just clean this up a little bit. Let me get rid of all these circles. Okay. So what do we notice about these perpendicular bisectors? They are all segment DE. DE goes through all of these, so DE is the perpendicular bisector of all of them. Segment DE is the perpendicular bisector to all three lines. Okay? Label the point at which A prime intersects DE at point O. So we want to label this right here and call it O. What is true about AO and A prime O? And how do you know this is true? Okay, AO is equal to A prime O. I constructed a perpendicular bisector, and O is the point where the perpendicular bisector crosses A prime, so it is halfway between A and A prime. Okay, moving on to discussion. You just demonstrated that the line of reflection between a figure and its reflected image is also the perpendicular bisector of the segments connecting the corresponding points on the figures. In the exploratory challenge, you were given the pre-image, the image, and the line of reflection. For your next challenge, try finding the line of reflection provided a pre-image and an image. Okay, so page 2 gives us the first example. Now keep in mind the challenge on the previous page. We drew segments from the pre-image point to the image point for all points on the diagram. That is not necessary. We were just proving that every midpoint is where the perpendicular bisector goes through the midpoint is the line of reflection. So once we've proved that, we really only need to do it for one point. So I'm going to draw a line segment from, it doesn't matter which one we do. You could do C to C prime, D to D prime, A to A prime, or B to B prime. How about we just do C to C prime? So there's the segment. Just trying to get it right. Perfect. Okay, there's the segment. And then I'm going to bring the compass down. And put the compass on the C. Open this up so I'm more than halfway, but not longer than this longer than the segment. Move it down to C prime. Draw a circle. Get my ruler. And draw a segment from one point of intersection of the two circles and the other. Okay, so now if I just extend that, I don't need to extend it. There is my line of reflection. So now it says, what is true about each point on A, B, C, D, and its corresponding points A prime, B prime, C prime, D prime with respect to the line of reflection? Okay, what's true about all of them? Okay, each pair of corresponding points is equidistant from the line of reflection. So C, from C to the line of reflection is equal distance as C prime is to that line of reflection, and it goes the same for the other 3 points. Okay, it says, notice on one very important fact about reflections. Each point in the original figure is carried to a corresponding point on the image by the same rule, reflection across a specific line. This brings us to a critical definition. Reflection. For a line L in the plane, a reflection across line L is the transformation R of a plane defined as follows. R sub L, actually. For any point P on the line L, R sub L of point P equals P. And for any point not on L, R sub L of P is the point Q, so that L is the perpendicular bisector of the segment PQ. Okay? Now it says if the line is specified using 2 points, as in line AB, then the reflection is often denoted by R with the subscript with the line AB down below, just as we did in the last lesson. Let's examine the definition more closely. A transformation of the plane. The entire plane is transformed. What was once on one side of the line of the reflection is now on the opposite side. Reflection of L of point P is equal to P means that the points on line L are left fixed. The only part of the entire plane that is left fixed is the line of reflection itself. Okay, does that make sense? What they're saying is, if I had a point P right here, and I reflect it across this red line, well, where would it end up? Right there where it is on P. So if there's a point on the reflection line, its reflection is itself. That's what that says. But if R sub L of P is the point Q, the transformation R sub L maps the point P to the point Q. In other words, if I had a point here that was called P, then I'd have to go perpendicular bisector that distance and then the equal distance over here, and that would put Q here. So what they're saying is if the point is not on L, a reflection across L would give you the new point. That's what this is saying. And then finally, the line of reflection L is the perpendicular bisector of the segment PQ. To find Q, first construct the perpendicular line M to the line L that passes through the point P. Label the intersection of L as M and N. Then locate the point Q on M on the other side of L such that the point PN equals NQ. So what they're saying is this point would be N, and there's another point M that created this perpendicular bisector, which would have been these 2 points here actually. So I should move M here and N here. They're talking about the 2 circles, intersection points. Points N and M form the line of reflection, and then P is the same distance from line MN as Q is. That's what all of this says. Okay, page 3, example 2-3. Construct the line of reflection across which each image below was reflected. Okay, so I need to draw a segment. Now remember, you need to do this with a ruler. I'm just doing it quickly with a tool on the computer that allows straight lines. So here you would use the ruler. I'm just saving time. So you're using a ruler. Wow, that's not very straight. Whoa! Try this. All right. That's better. So there is a segment from A to A prime. Then I get the compass out and I put it on my pre-image point A. I'm going to put my pen down and use the mouse. Okay, right there. Open the compass so that it is more than halfway, but not more than the length of the segment. So there's the circle. Move the compass to A prime. Do not change the radius. Draw a circle. There are my 2 circles. Draw a segment using a ruler. I will show that with a ruler. And we're going to draw a segment, I'll use green, through those 2 points. Okay, there's my perpendicular bisector. So D is the same distance as D prime from this bisector, and there is the line that this ABCDE polynomial was reflected across to A prime, B prime, C prime, D prime, E prime. Okay, so now we're going to do the same with M. Okay, it doesn't matter which point you choose. I'm just going to do the point at the bottom of the M right here. And I'm going to draw a segment from that point to the other point M right there. Okay? Take the compass, put it on the pre-image point, which is solid, not dashed line. Right there. Let's change it to blue. Open this up so you're more than halfway. Okay, more than halfway, but not longer than the segment. Draw a circle. Move the point over to the image point, the copied point. Just trying to be as accurate as possible. Right there. Draw a circle. And then connect the two circle intersection points. Do that in purple. And there is the line of reflection. So if I took any other point, such as this 3 right here, it would end up 3 prime right here. Okay, so let's label this up a little more. This went A, B, C, D, E. So if I put a point here and called it F, and put a point here and called it G, then that would have been segment FG. Actually, it should be the endpoints, I guess. Doesn't really matter, but let me move that to there and move this to, this keeps exploding on me. There. Okay, so there's FG. All right, and then this, let's just say, that's actually problem number 2. This is problem number 3. And so let's start with, I don't know, it doesn't really matter. Here's A, here's B, C, D, E, F, G, H. Why did I draw an F? G, H, I, J, K. So A is going to become A prime. B is here, B prime. C prime. D prime. And so on. Okay, and then if we named this the perpendicular bisector, we ended up at K. So if we called this point here L and this point here M. Okay. So it says you have shown that a line of reflection is the perpendicular bisector of segments connecting corresponding points on a figure and its reflected image. You have also constructed a line of reflection between a figure and its reflected image. Now we need to explore methods for constructing the reflected image itself. The first few steps are provided for you in the next stage. Okay, page 4 brings us to example 4. The task at hand is to construct the reflection of triangle ABC over segment DE. Follow the steps below to get started, then complete the construction on your own. So one says to construct a circle A centered at A. Okay, so they just drew this circle centered at A. Didn't matter what the diameter was or radius. And it says, oh, it does matter. It says with a radius such that the circle crosses segment DE at 2 points. So there are 3 ways we can draw. We could draw a circle that was so small, like here, that it never crossed DE. Or we could draw a circle that was exactly the radius distance and only touch at 1 point. Kind of having trouble doing that. Let me do it with a circle, just so you get that idea. There are 3 ways to draw a circle. So if I drew a circle centered at A and I stopped here, it never crosses, does it? But if I move it out to here, now DE is called a tangent. It touches at 1 point and only 1 point. That's not very helpful. We need to draw the circle so that it's large enough to intersect DE twice. So any one of these circles until I get to the point where I'm beyond that point D and I'm off the segment at one side. So any circle of this size right here is okay. Anything from here to about there. Okay, just make sure the circle is crossing at 2 points. All right. And then they labeled it the intersection points F and G. 2 says to construct circle F, centered at F, radius FA. Okay, whoops, touched that screen, didn't mean to. Radius FA. So circle centered at F with a radius of A. So they put the compass here. They opened it up to the original point, drew a circle. Then they put the point of the compass on G, centered at G, radius of GA. Label the unlabeled point of intersection between circle F and G as point A prime. So the other intersection would be the reflection of A to A prime. This is the reflection of vertex A across DE. Repeat steps 1 and 2 for the vertices of B and C to locate B prime, C prime. So that's what we're going to do here. So I get the compass out, put it at B, try to be as accurate as possible. This is really difficult with a mouse. Okay. I'm going to rotate it sideways. I'm going to open it so I'm just beyond the segment, and I'm going to draw a circle. Okay. I just created 2 points. So we already used FG. How about H, I? So there's the points H and I. So we just did that. So you draw a circle so that it crosses the segment twice. Then you put your compass on one of the points. Open it so that the radius is the distance from that point to your pre-image point that you're reflecting, which is B, which is right here. Now notice I'm off just a little bit. The program does not allow me to land right on that point, but it's pretty close. Let me change this to red. So then I draw a circle. See how it's off a little bit, but if I extend it out, I would have been too far. So this is going to be close, but not perfect. And then I do the same centered at I, radius going up to B again. So as you can see, I'm off. But if I put it here and opened it one more bit, computer generated, oh, I guess that is better. How about that one? So then I will delete the inside one. Okay, I'm trying to click on the inner one. Okay, so there are the 2. So this point down here that it intersected my 2 red circles is B prime. Okay, and now we're going to do it one more time, but just to avoid confusion, I'm going to delete my circles that I've created. so it's not getting too messy here. All right, so then I'm going to take the compass and I'm going to put it at C. Right there. Rotate it around. Okay, I'm hitting E here. It's not too large. I don't want to go through I though, so I'm going to make this a little bit smaller. Draw a circle. Okay, there's one. All right, so now I have 2 points. I'm going to label them J and K. So here's J, and here's K. I'm going to take the compass, move it down to J, rotate it, and make a radius that's going through C a little bit larger. How about here? That's pretty close. Can't do much better than that with the program. Put the put the center of the compass centered at K. Rotate around. So now you see these 2 blue circles down here intersected at C, and the other intersection would be the reflection point C prime. Okay, so let me get these circles out of the way. And now I'm going to draw segments from, and I suppose I should use the ruler. So I'm going to start with my segment A prime, B prime, which goes from this intersection point here down to B. Okay. And let's make it orange. So there's A prime, B prime. Rotate my ruler over to C prime and do A prime, C prime. Okay. And then move my ruler to B prime and draw the last segment B prime, C prime. Okay, and there is triangle A prime, B prime, C prime reflected across the given segment DE. Now it says things to consider. When you found the line of reflection earlier, you did this by constructing perpendicular bisectors of segments joining 2 corresponding vertices. How does the reflection you constructed above relate to your earlier efforts at finding the line of reflection itself? And why did the construction above work? Okay, that's kind of an open-ended question. See if you can answer that on your own. I'm going to move on to example 5. So now it says, now try a more slightly complex figure reflection. Reflect ABCD across EF. So now we're doing a quadrilateral, my fault. Okay, we're doing a quadrilateral, 4-sided figure. All right, so let me get my compass, bring that down, and my ruler. Okay. Alrighty, so here we go. So what did we do up here? We put the compass on, let's use C because it's the closest. And we're going to draw a circle. There's our circle. Then we're going to put our compass at one of the points of intersection, rotate it, move the compass to a point so that the intersection G, let's call it, let me just do this. Let's call this point G. Okay. A, B, C, D, E, F, G. Draw a circle. Move the point so that we're drawing another circle centered at H. So I will put a dot here and call it H. That's the other intersection of the circle centered at, oh no, I'm sorry, not that one. This one. This is H. My fault. Okay, so I should label those first so I don't make that mistake. And then draw a circle centered at H that goes through our point C, and where those two black circles intersect is C prime. Okay, and this is going to get really cluttered, so I'm just going to delete my circles. I would highly recommend, if you're doing this on paper, to do colored pencils rather than erase, and just use colored pencils and keep going. Alright, so there's C prime. So now we're going to do the same with B. So you put your center at B. Move your compass up so that it's, see, I'm open too far right there. I'm going outside. So I need to draw a circle that will cross at two places, right there and right there. Okay, it just so happened to be G again because of the radius I chose, but it created this other intersection point, and we used H, so let's call this J. I probably shouldn't use I. So that's the point J. So then what do? We use the point G and J to construct circles centered with a radius centered at the two intersection points with a radius of the length of G to B, for instance, and I'll use red for this circle. So there's one, and then move and draw a circle centered at J with the same radius going through B. Okay, so I'm off a little bit there, probably because of the program. Let me try that again. Let me try here. Okay, it's pretty close to B. Alright, so that's going to create this point right here, and we'll call that B prime. Let me erase my circles. Okay, and now I'm going to, let's see, we've done B, we've done C, let's do A. So I put my compass here, rotate it around. Notice the radius isn't large enough to reach segment EF, so I'm going to extend it just beyond. Draw a circle. Hello? Must be out of ink. Alright, there it is. There's a circle intersecting two places on EF. So I'll name those points. Let's see, we're up to J, H-I-J, so this will be point K. Let me change to blue. Right here is K. And right here is, let's call it M instead of L. Alright, so then we're going to put our compass on K with a radius of KD. Draw a circle. Move it to the center of M, or let's see, not M, yes, M. With a radius of D. Okay, I don't know what I was thinking there. That's not right. Okay, so let's recap. What are we doing? We're looking for A. That's where I went wrong. Okay, so we do use the point on the red circle K, the point on the red circle M. I want radius A, not D. Okay, sorry about that. Hope I didn't confuse you. Hopefully you caught that. All right, so I want this. So notice I paused there for a moment because when I drew that circle, I'm like, wait a minute, that's not a perpendicular bisector if I drew a line through there. So always pay attention to what you're doing, and if it doesn't make sense, question it. Okay, and then finally we draw a segment. Or draw, well, we don't want to draw a segment. We don't need to draw a segment. We just want to label this point. So this was A right here, so this would be A prime. And again, I'm off a little bit, but it's because of the program not allowing me to snap exactly on. You should be more accurate with your compass. Okay, so now I'm going to pause, or I'm going to erase the circles. So we've got A prime, B prime, C prime, we just need to do D prime. So I put the compass on D, centered at D, rotate it around, so I'm going to cross the segment at two places. Don't make it too small, don't make it too large. I'll draw a purple circle this time, and that's almost too large. I don't want to go that large. So let me make it a smaller radius, and now I'm hitting it at two places right there. Okay, so that's centered at D. Actually, it was kind of moved, wasn't it? It's not quite on D, so let me redo it. Here's a circle centered at D, crossing G or EF in two locations. The two locations are, I'll keep it purple, a little bit inside of J. It's right there. And where are we right now? KLMN. So this is N, and this is O. All right, we're almost done. So now I'm going to take my compass, draw a circle centered at J with a radius of JD. Right there. And then move it over to O and draw a circle centered at O, radius OD. And again, I'm off just a little bit, but it's close enough for the explanation. So this is D, so now this is D prime. I'm going to delete my circles so it's not messy. Okay, move the compass and ruler out of the way. Actually, I need the ruler. So now let's construct these by connecting the dots. So we're going to make segment A prime, B prime. I like going in alphabetical order because when we name objects, we usually go in either clockwise or counterclockwise. We don't bounce around. Okay, we can't skip vertices. So I'll do it in red. So here is A prime, B prime. Now we'll do BC. And then move my ruler down to C prime. And draw CD. And then finally, D prime back to A. So we have just reflected quadrilateral ABCD across segment EF and formed quadrilateral A prime, B prime, C prime, D prime. Okay, page 5 brings us to the end of lesson 14. Review the lesson summary and go to your problem set.